Believe it or not, but this lamp is lighted on with a battery made from only household items. And it gives quite a large amounts of light. Let's see how I made it. All the things you need are here. First, a glass container, some copper wire, a piece of aluminium foil, and a little bit of salt, and a few crystals of copper sulfate. Everything starts with a glass container, inside of which I'm gonna put a good amount of table salt. Now I'm gonna fill the container with water and let the salt dissolve. It's a good idea to use hot water. Now let's bend the copper wire in a way that it can enter the container. After that, let's do the same with the aluminium foil. These two are the electrodes that the battery will use. It's a good idea to connect some wires to the electrodes now, at this point, but I forgot and connected them later. Now let's put the copper electrode inside first, and then the aluminium electrode. Keep in mind, the two electrodes must not touch at any point. Now let's take some of those copper sulfate crystals and put them at the bottom of the container. They have to stay there. Don't mix the solution. It's very important not to mix the solution. Now let's measure the voltage and see what we get. The voltage is around 0.68 volts. Okay, it's not too high, but not too bad either. But what current can this cell give us? Let's see it. Let's hope that the current is not too low, like a couple of milliamps. That way it would be useless. And the current is... Whoa! 1 amp! I wasn't expecting that. Now, let's connect those wires to the electrodes. It's not a good idea to do this now, but I forgot before. The reason is you don't want to disturb the layer of copper sulfate at the bottom. You want the copper sulfate to stay at the bottom and not come up. Now, I'm gonna connect a lamp to this battery. This is a special lamp because it has inside an inverter circuit that will invert the 0.7 volt of the battery to around 70 volts. And voila! The lamp lights on. We can do this only because the battery can give a substantial amount of current, around 1 amp. The battery inside is bubbling because it produces some amount of hydrogen as a byproduct. The good news is that the lamp gives quite a large amount of light. Now stay tuned if you want to see the explanation of how this battery works. Now let's see what happens. In the solution we have submerged 2 electrodes, one anode of aluminium and a cathode of copper. At the bottom of the container, we have solid copper sulfate crystals. Now, those crystals start to dissolve and create a layer of copper sulfate solution. For this kind of cell to work, the layer of copper sulfate solution at the bottom must not dissolve in the entire container, but must stay at the bottom. Now, some of the aluminium atoms go into the solution, but leave the electrons in the anode. This gives to the anode a negative charge, because it has an abundance of electrons. Something similar happens to the cathode. At the bottom layer of copper sulfate, some of the copper ions deposit on the cathode, but they have a positive charge, so the cathode becomes positive. Now we have two electrodes with different charge on them, so we have a potential difference between them. So if we connect a wire between them, current will flow. If we want to make useful work out of it, we can add something between, for example, a LED lamp to light up. Now, as a conclusion, we can say that at the anode, aluminium is oxidized. It gives aluminium ions and electrons. Those electrons go and reduce the copper in the copper sulfate solution. So, the entire reaction is copper ions plus aluminium gives copper metal plus aluminium ions. I made a mistake there. Is aluminium plus 3, not copper plus 2. Now let's make some calculations. 2 moles of aluminium give 6 moles of electrons, which means that 54 grams of aluminium give 160,000 milliamps hour. A really big value. Which means that a piece of aluminium like this, with a mass of 10 grams, gives 30,000 milliamps hour. For comparison, let's remember that a smartphone lithium-ion battery these days has a capacity of around 5,000 milliamps hour. So, a piece of aluminium like this can give much more current than a lithium battery. Well, at lower voltage, but you can add more of these batteries in series and make a higher voltage. Okay, thanks for watching and I hope you really enjoyed this project. Goodbye.